member of Solace, and very passionate about integration and event-driven architecture. Have decades of experience, done many roles. That's about me. Why I'm here? Talk about event-driven architecture. So let me start out with something. How many of you are familiar, sorry if it's a wrong question, are working with event-driven architecture? Nice, nice. No, I have a majority who can enjoy, at least benefit from this. Thanks guys. Very good. So the agenda is going to be, it's not something new. Digital transformation journey. That's what we call it today. Pretty much every enterprise talks about digital transformation projects. This is not new again. A couple of decades ago we started with that, and we went from computing to distribution to finally we are event-driven architecture. We will appeal these layers and figure out what it means to say event-driven architecture, and also get a perspective of developers and architects. What does it mean to say event-driven architecture? What would be their expectations, right? We'll talk about that. That will cover some of the essential characteristics, and then specifically governance, and then we know the APIs that are driving the world today. In other words, REST API. So what is the new type of API that's coming into the play? And how is it going to exist? As a standalone, or is there any convergence? Both are possible, we'll look at it. And bust a few EDA myths, because people have good understanding, at the same time there are a lot of information floating around, misleading people to make some assumptions. Let's bust a few of them and talk about EDA in cloud, because without cloud nothing moves today, right? And last, I'll talk about our product very briefly. I'm not here to talk about the product, rather to bring you awareness on the EDA. That's my primary goal. Hope I do a good job. I'll hear it from you. So let's talk about the digital transformation journey, right? With the advent of computers, one of the things that we did is we want to put the computers to work for us. Great. One computer, two computers, more computers. Okay, let's distribute, rather build applications and build systems and run it on these systems. And as a consumer, as a beneficiary perspective, we treat them as a single unit. All of these computers are serving one application, or all of them represent one system. We did a good job. This is the age-old IBM mainframe to the network computers, right? And then came the distributed communication. What do you mean by that? How do we let these applications work with each other, collaborate with each other? Okay, we'll put a file system in the middle. So when a file gets dropped, the other guy will wake up and do the job. No, we're going to put database. So things evolve. These were doing great, but things kept moving. Next one, network communication. At a socket level, we come up with the protocols based on TCP/IP all the way to WebSockets. We're going to communicate in real time as to what I want to tell you as a peer in the communication protocol or the application systems, right? So the network system, basically the network communication took care of most other things. In all these things, if you notice, the three critical needs are basically ability to pass data and state from one application to another application, right? And next one is ability to trigger or send notification, saying that, hey, start a job, or I completed my job, right? And then the last piece is about scale. That's word of the day today, right? Everything needs to be at scale, right? All these things, if you take it as a check mark and then see if the distributed computing ticks off all the things, the answer is no. Distributed communications, can it solve? No. Network communication, pretty close, but scale is a problem because it is location aware and you cannot distribute it agnostically. Then came the notion of middleware and integration, right? If you remember, even a decade ago, the JBoss, WebLogic, WebSphere, these were all middleware solutions. They did a great job. They created this location, location transparency, and they were able to trigger and signal based on a message-oriented architecture, and they also provided some scale, and they were supporting distributed ecosystem. But the problem is they ended up doing a lot more than messaging, right? So it became heavy, fat layer. What the need of the hour is to slice that and then create this plumbing layer, just simply moving data between systems, between applications, between the peers, and then let the connecting to ERP, connecting to other ecosystems, lead to a different layer, right? So slicing this and creating something what we call as a event broker, that's the norm today. Any of you listen to this AWS reInvent videos?
Yeah.
There is Dr. Werner video. Fantastically talks about event-driven architecture. More than event-driven architecture, it's about asynchronicity, right? I highly recommend when you go back, check out that video. We have been in the industry, not just us, Confluent, RabbitMQ, so many other vendors are there in this field. We've been working very hard to create the awareness and build a kind of a platform on which better solutions can be built in real time, right? But AWS is embracing this thing 100%. There are at least 6 to 7 talks on asynchronous communication and event-driven architecture.
Who is the speaker?
Dr. Werner, I forgot the last name, Dr. Werner. I can share you the link at the end of the session. Yeah? So there is more awareness, Whatever we say is good, but when AWS gets on the podium and make the entire convention around this, that is the theme, literally speaking, right? So check it out. So we got a stage set for Event Broker. How did we get here? We moved from the distributed computing, communications, network communications, middleware integration down to Event Broker. That's the layer that's going to get you the low latency, high volume, or the high throughput ecosystem. That's the need today, right? Because everything is in scale. I'll also call out why it is at scale. And our requirements didn't stop there, right? We want to run across all the environments. It used to be only on-premise solutions, and then maybe private cloud in a data center. Now we have public clouds, and we want solutions to cross the cloud boundaries. And then also do a hybrid, in-premise, all kind of possibilities. We want some of them or all of them. And we want the integration across multiple protocols, including REST, because the world runs on REST today, but there are other protocols that has evolved, around the messaging. And then the security, this is a new paradigm, right? The whole event-driven architecture and event-based communication. The whole notion of the role-based access and security controls, they are slightly different. They could be still based on the TLS, SSL and so on, but the permissioning system, right? That's slightly different from a REST perspective. Something that we are all used to. So look at that. And we want high availability and 99.999 uptime, robustness in everything that the system does. Monitoring and governance, that's one of the things as an architect, first thing that you would care for, right? Obviously, at the end of the day, all these things put together, we want a mediated system. That is event-driven communication enabled system. In the entire scheme of things, one thing that should stand out is asynchronicity. Right? Today, whatever we have, be it RPC-based system or a homegrown system built on plain sockets or anything that you have today, REST, including REST, based on HTTP, they are all synchronous. We are going to break from that pack. We want to create an asynchronous system. When we create a system like that, we are going to be inclusive. We will have support for existing things. We cannot create a new world overnight. It is always about coexistence and then right tool for the right job. Let the field industry decide that.
How about Chris Richardson? Even he did work on more on event-driven as well as, let's say, specifically focused on this event brokers.
Yeah.
So,
from his perspective, he's a pioneer in patterns, right? In microservices especially.
right.
Microservices without event-driven, we have been doing for the past 5 years, if you notice, using REST. Now, we already know what are the issues with the REST-based microservices. Orchestration, observability, failure handling, failure propagation, how to determine what's happening at any point in time. Those things are solved by event-driven. Right? So microservices is a great candidate. Event-driven microservices itself is evolving as a domain. And Chris Richardson talks a lot about that. Yeah. So rise of event-driven architecture. It's not something new. In various names we might have been kind of dealing with this, but it got a formal semantics around this. And there's standards are evolving. So, but before we talk about architecture, let's make sure that we get our thinking turned around, because it's all about a paradigm shift. So far, our world has been around like server client, requester, and then a responder. Now we're going to go around and say that no, world is full of events, and there's going to be a publisher, there's going to be a subscriber. So slightly different thinking. So let's set the stage for that, and on that basis, let's start with what are events. Give me a second, I'm expecting a colleague. Guru, somebody, can you help? He's trying to get in here. I'm sorry, my apologies.
No problem.
So, when you talk about events, events are everywhere. Anybody who started out in the early days of programming, any UI programming, for me at least Windows 3.1 and 98, whatever, Windows 3.1, UI programming started with this term event. A click is an event, sending data from control to control is an event, and kind of continued with this, right? UI programming is built around events. And till today, even if you go to the DOM, in the modern browsers, events. So events are not alien to us, right? It's been around and we have been doing a great job with that. Just that the thought shift of using events in the enterprise context. That's where the game starts, right? So when we talk about events, you'll know more. But before that, let's get a hands-on something. I know you guys had a good lunch, probably a little ready to go, snooze. I'm not going to let you snooze. Get up and do some exercise. I'm just kidding. So we know this dragon boat race, our own God's own country, Kerala. Every Onam we have this boat race. Bunch of people team together and take a rowboat, keep rowing. Whoever touches the finish line first, they are the winners. Take that thing, it's a game basically, right? If you were to build a game like that, how do you do it? Right? Keep thinking, but before that, can we play the game to start with? Let me just... because there is no more fun to learn something by participating than looking at the slides. It'll also give me context to... Just a second. Alright. A screen should come up now. You did? Okay. Oh, this is bad. Okay. If you can, I don't know, the QR code is scannable. Can you, in your mobile phone, just scan this QR code or open a browser and go to this sd.salas.com/db. Let me know. Hope it works. It's coming up? It's able to read, right? Sorry. My mistake. Okay, go by the URL. My apologies, I don't know. It came? Okay. Worst case, sd.salas.com/db. Let me see. Please feel free to join. It's a simple game. You don't have to move anything except your thumb or the fingers. So 14 people join.
It's also asking to join Rahul.
Join Rahul.
Yeah.
So race name it's saying Rahul.
Yeah.
Go for it. Go for it.
Go for it.
Yeah. I mean, you can see the number of joinees are increasing, so it might be the same thing. Alright, so what you see here is a race controller. It started the race, waiting for players to join. And each one of you kind of either scan the code or went into the URL, you're automatically put into a team. Now, with a single click as a race controller, I should be able to start the race. Can I start or is still people are trying? Okay.
So 3 joined here, there is 20.
Really? Maybe you went...
It shows I'm on the LOD.
Oh, you finished. Can you restart please? Something happened here.
I'm on the LOD. Still in the team page.
Not started, right?
No, not started.
Yeah. Just if anybody is saying game completed, please redo the join process. No, not Rahul. Oh, yes. When it comes up with a pop-up question, join Rahul, no. Join Devjan. Yep. Alright. So no worries, if you participate,
You're in orange.
yeah, good. So as you join, you will be put on a team, 4 colors, pink, orange, green, blue, whatever, right? So with a single click, I will be able to start the race, right? And all you need to do is on your mobile phone, just tap. Tap, 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 tap. That's all it is. Alright? On your marks, get set, go. Okay? Go, go, go. Okay, Pete? Who's that printing? Oh my goodness, you guys are so fast. How many clicks? Okay, there is some goof up here where it's a part of the people join at different rates or whatever it is. We will, if time permits, we'll do it one more time properly.
No,
But
we didn't even get that screen. We are still yellow team.
we are in the second batch.
You have to click there.
Once you say start, we should stop it.
Yes.
Before you say start, we start that.
No, get set, go came, right? So the time it opens up for you to start clicking. No worries, we will do it one more time as time permits. Let me talk about this. What we are looking at is a game application. As an architect, if you were to use the existing tools, first thing is client server. Okay, there's a server listening for people to join, and then clients are mobile, various form factors, and they register, and then whenever I click on something, the race starts. Just great. But extend this. Client server designates some component as a server, and rest of the components as clients. In here, if you notice, the communication is happening bidirectional, and it's asynchronous. It's hard to get this done with the traditional client-server thinking, especially even specific REST APIs. We need a different paradigm. That's where this event-driven thinking comes into picture. So what happens here is, there is a broker, where the controller is also a client, right? It subscribes to events that correspond to your tap activity. It also subscribes to events that indicate that somebody is trying to join. And it also has a logic upon receiving those users joining, put them on a team, and then broadcast that or send it as an individual message to you. So you see the event is the one that's floating around. There is no server, there is no client. There is a producer or consumer, publisher or subscriber. You understand? So this is the thought shift we need to have, right? So this is like a simple example. But don't worry, we will have a game one more time. I'm sorry. The fun part is, with this thing, we think that, okay, gaming is the greatest candidate. The answer is there's a lot more. This thinking has gone beyond. Let me get back to my slides.
One question I have.
Yeah, please.
Does the data is stored anywhere?
Data is stored anywhere. Obviously, right? But what kind of data are we talking about?
Now the user data plus who has won and all the count and all things.
Yes. See, every click that you brought up, let me fix this display. I don't know how to. Oh yeah, here it is. It's a separate display. Okay. So yes, the data is stored. See, the events that got generated, right? That carried some information. That could be your user credential, whatever the 8-digit character, random string. And then the response going back would be a message that says that you belong to Pink team. And you tapped 5 times, right? There is data. But is it stored or not? That's a quality of service.
No, that is the client server architecture, right?
Which one?
Means I am the user.
Yeah.
And some data is stored there. That is the place where I stored. That is a server.
Part of the thought, I will answer this question with precise information because it's slightly different. Event is data. Event is a wrapper around data, right? When you receive an event, what do you do with that? You can just consume it and then publish something else, move on. You don't store it. That's called as a, direct messaging. Everything stays in memory. No, I want the message to be available even if I go down or broker goes down, then it will be put on a disk. So that's a quality of service in terms of what class of service you are offering. That comes down to another component. We haven't seen that component in the picture, something called as broker. That's what we are going towards, okay? So with this notion of treating the whole world as events, and then we're going to pass around events. This thought was prevalent in the gaming industry, and in UI programming, and most of the programs are familiar. Things have changed, even the enterprises want to use. Let's take a simple example. We know the supply chain disruption that happened in the COVID time frame, right? Even otherwise, some Egypt ship getting stuck, or hurricane. These updates about the GPS location can give a hint to the warehouse how much delay I should expect, right? So this is an event. As the ship moves, sending its location in real time will help you to calculate how much delay to be anticipated. So that information is so critical, you can kind of bubble it up to other applications. So one event can trigger multiple other things, right? This is one example. If you continue, it doesn't stop there. Okay, fleet management. A truck arrives at the warehouse and you need people to unload. You're not still there yet, it automatically unloads, right? But the crew is pretty expensive and it's overbooked. How do I let them know that plan for unloading at this point in time? Just to trigger that this truck has arrived on this gate G, whatever, right? So this is a good example. All these examples that I'm discussing about, these are real world solutions where EDA is in use. The next one is, it's not just about the systems and applications that we know, like processes. It's a lot more than that. Previously, when you deploy an escalator, you're done, and when there's a problem, somebody will come and call, and then dispatch crew, repair crew will come and fix it. No, there are devices that can send out a message. Hey, there's a breakdown in this motor. That information can automatically be broadcast or propagated to appropriate devices or maybe systems that can dispatch crew immediately. Where people mobility is so critical, like airports and other places, this kind of automation takes a long way. You know, Singapore is a smart city, by all means, right? Their smartness comes from automating these things, integrating these devices. Even today, we know the smart bulb, right? Just because it has an IP doesn't make it smart. But being able to tell that, hey, I have a voltage fluctuation, or maybe I have only 3 days life left. Because it may have internal measures, right? So being able to share that metrics and information to the outside world to make some decisions, that will help, right? So this is a device-centric example. And then onboarding, a new phone is launched. The first thing is, there's always a queue, but still you will run out of phones. Apple, for example, right? So how do you keep the inventory on check? Hey, I had 1,000 shipped, I'm already at 888. So tomorrow my demand should be increased by, supply should be increased by 20%. Some kind of a forecasting can also be integrated into this. And the most important piece is trading, be it stock trading, capital markets in general. Foreign exchange is something that fluctuates by by seconds, literally, right? So how do you enable this kind of foreign exchange trades? And this information is not local to you. When you are purchasing USD price is not determined in India. It's determined somewhere in the NYSE or some other exchange that's running the show. How do you get that information? That has to be real time, right? And then there are traders sitting and watching when it is going down, when it is going to go up. Right? They are playing on that. Their decision making depends on the real time nature of this data. Now you see, if you use a REST-based approach, it's going to be pull, right? What you need is a push. Just tell me what happens, what's happening, right? So these are the real world industrial use cases. And we have customers on all these brackets, right? The last part I want to call out is, you asked the question, data versus event. Data is event. When you send a data, you may say that, hey, start your job, that's a trigger. But still you have a data kind of encapsulated in that REST request, saying that this is the job I want to start. Same thing can happen in an event. Event could be a trigger to initiate some change, or it could be carrying the change state itself. Okay, I started a job, this is the job status. No, even in the e-commerce site, you place an order, you keep refreshing the page. That's our REST side. What if your mobile gets notification, your order is shipped, it's in the warehouse, and it's in your courier center? We know that, right? Those things happen through event-driven design. Event-driven architecture is the fulcrum of all those real-time interactions, right? In a big picture, it's been kind of a mantra. All the analysts have called out this one, need for speed. You know, when you have the data in hand, when you need it, in real time, you can do magic. That magic is what we are driving the world towards, right? AI, ML, predictive analytics, preventive analytics, and so on. This is all history. We know BI, we know this reactive systems, but they all had a lag of at least a second, minute, days. Those are all history. Today, every system needs now, real time, right? So this has been the case, and all the analysts who are kind of monitoring this industry have been educating the masses with this kind of statistics, right? Now let's get to what is event-driven architecture.
Okay. See, let's go back to non-IT. Let's say technology was not there. 50 years back, there was event. As you said, logistic. Worldwide, they had a hub. Every hub has hundreds of events, right? At least 20, 30 hubs were there in global.
Yeah.
So earlier they did not had even 100 years back.
Yep.
The event driven came physically in the real time, right?
Yes.
50 years to 100 years, take it from 100 years to
See.
50 years, it evolved.
What do we do as humans, right? We imitate nature the best. Nothing was there, we used to send pigeons. Then came the phone, then came the telegrams, then came something. All the things solve the problem of a certain scale appropriate to that timeline. Then the scaling problem came. Okay, I'm going to dedicate a person handling 5 phones. Okay, he can handle only 5. And then beyond that, technology was not there to support 10 different lines.
Okay.
Even if it does, humanly not possible, then you will have an army of people sitting. That's not practical. But as we move forward, the technology and the techniques, the thought process evolve. So, as I said, you're right. Event-driven is just a brand new name that we have given to this domain.
Okay.
No question. But it makes a difference in terms of understanding architect's perspective, right? We saw the world as a synchronous. Now we need to see the world as asynchronous. How many of us have implemented asynchronous REST-based projects? I'm sure yes, but was it easy? Right? So right tool for the right job is another mantra that we all the time we use, right? So we got a right tool now to solve this asynchronous requirements in terms of communication, interaction, system design, architecture design, and so on. Right? Let's make the best use of it. So looking at the definition to become more clear. Right? Let's get this right. It is an asynchronous communication between applications via publishing and subscribing events. That's it. There is no requester, sender, receiver, nothing. Events produced, events consumed. And the key point is the event mediated through an event broker. This is the one magic component sits in the middle. That's the job for you. That's the one that gives you the scale, low latency, high throughput, connecting the dots. How do I know who's subscribing? As a sender, I just want to send out the message or event. Right? The broker is the one that choreographs, is the one that captures this interest and then delivers these events in time to these subscribers. Right? We'll talk more on that. So, getting to the definition, event could signal a change in an application state or an action or command. If you guys know this programming pattern, CQRs, right? When you want to read, you issue a query. When you want to act, kind of issue an action, then you issue a command. But in the REST world, you cannot distinguish. In events, you can do that. A trigger is just a trigger. Whereas the state change being broadcast like a ticker price, stock ticker price, that's the state data. So it can be used for both. And most important thing is events are immutable. What does it mean? They are snapshot in time. You cannot change the history. Same goes. Once the event is generated, that stays fixed. Right? So we are not here to do simple things. Right? We want to solve enterprise scale problems. Where does it start? It starts with a simple enablement. Enabling event-driven for an enterprise, right? There are so many things happening. When a customer buys a certain product, that can trigger something that can fan out into various other systems that need to know this action in time, right? Similarly, we talked about the elevator getting stuck, or a temperature sensor showing out of bounds, or could be a device, a passenger boards the flight, right? Oh, by the way, one of our customers, couple of our customers are aviation industry customers. Starting from the moment you check in, all the way to you board the plane, and then you get out. Everything is coordinated through event-driven, asynchronous. So when you check in, automatically if there's a delay, you will be notified. Or you are the last passenger, arrangements will be made, right? So you get the picture, right? So these use cases are real in event-driven, in the enterprise. But what do we do with that, right? Applications need to know about it. What kind of applications we are talking about? If it's a customer placing an order, it could be the inventory system. Then you say, hey, I don't have inventory, so you don't even accept the order, right? Or it could be the credit check, right? So there are so many dependent systems that can make these decisions and enable your experience, customer experience, if they get to know this one trigger, action or change in time. So enabling is all about capturing these events, broadcasting it to dependent applications, and let them do whatever it needs to do. Whatever it needs to do is the one that's business logic, depending on whether it's a retail solution, or fleet management, or airline management, and so on, right? So if you look at it, doing something about it is the key here. That's the only business logic as an architect you'll be focusing on building. But when you adopt EDA, rest of the things, it's a simple fact of design, how you will design an architecture, right? Oh, I'm going to put these systems, I need scaling here, so I got to have multiple instances, and I need parallelism here, I need concurrency here, I need fault tolerance here. Those things are still valid here, nothing changes. Just that, how does the business logic gets triggered? That is a different kind of thinking with respect to other things. Events need to be generated, that's the first enablement. And then how are these events going to be consumed? What actions to be taken? That's your business logic. Right? So put it all together, what we are looking at is, we're going to generate more data. It would have been a big issue 5 years back. We don't have bandwidth to push even our regular files. What are you talking about? More data? No, things are different now. Our phone has 5G. It can push a bunch of data, gigabytes of data. And then fibers, right? So network is not an issue anymore. Maybe we'll hit the wall soon. And storage is not an issue because we have the ability to scale dynamically when you choose cloud as an option, right? So things are easing up quite a bit. From an enterprise perspective, people are just jumping into this bandwagon. All the new projects are starting as cloud native from day one. And even the old ones, they are slowly migrating to cloud. That used to be the case of banking can never move. No, that's not true anymore. The majority of the pure digital banks exist, and then even the old school banks, they are moving to cloud, partially or fully and so on, right? So what it means is EDA makes it possible to get all the information when we need, where we need, in real time. That's the crux of it, okay? So an EDA platform would look like this. What do we need, right? We need an event streaming. Streaming is basically the ability to stream events. When you send API, it's a request and you get a reply. Maybe more than one reply, that's fine. That's all packed as one reply for you. Here it's not like that. We need to stream all the events so that anybody who wants, they can get it. And then ability to manage these events. What is the meaning of management? We publish an event, somebody gets it and we are done, right? No. There is a whole governance notion. Who's permitted to receive this type of event? What's the schema that are agreed upon? Just like our traditional thinking, we've got to have these contracts, understanding in place. I wouldn't use the word contract here, rather the application, events, and schema. This is a kind of hierarchy. An application will tell you what events you can publish or subscribe. That's a permission aspect. Right? When you say, I can publish this event, okay, what schema of payload that you will be tapping into? That's the data aspect. Right? So, it requires equally important governance scope to be put in place. That's also part of an architect's job. Right? And the last piece is insights. Okay, this is great, but what's happening in my system? How many events are published? What's my throughput? What's the latency? Who's the slow consumer? Who's the fast producer? Is there anything that I need to know so that I can manage it? Or maybe is there a version mismatch error? Some consumers are throwing errors. Why are they throwing errors? We need to know, right? Those insights is equally important. So instead of looking at EDA as an architecture, when it comes to adoption, you should treat that as a platform adoption. The platform comprises event streaming capabilities, event management, and event insight. All these things are meaningful on top of something what we call as a broker. That's the central piece here. Broker is the one all these producers and consumers will be talking to. They need not know about each other. Right? I can send a Giri arrived. That's an event. When I signed up, Giri arrived. What if he put in a system that goes as a message to Guru and other members of the organizing committee? They can immediately send somebody to have me come in. Right? So like that, he didn't know that, where am I? All he knows is Giri arrived. And he knows what to do. So those kind of decoupling or loose coupling. All those things are facilitated by this event broker. Right? I'm touching upon a very meaty topic, we can keep talking about that, but I just want to highlight this. Mediation is a central theme of event-driven architecture. All the events exchange goes through a broker. Right? And of course,
how can event insights can be broker job? Because it is more to do with the analytics. So I do understand event broker can be used for event streaming or the event management. So they can event broker, they can participate through event broker, right? Mm-hmm. But how about event insights? Event insights.
Totally. Just see this other way. Event broker is the starting point. That's where the action happens. When you say events are stored to be delivered later, they exist in the broker. So broker is the place where you have a kind of a tap on everything what's happening. So that's where you build the event insight. So that means a layer above, these are applications that are built on top of the brokering capabilities. Right? So it's not the job of the broker. Broker simply does the event routing. But in that process, it generates a truckload of metrics. That metrics somebody has to capture, not your API or client. Because if client would be interested in giving my event, I move on. Right? These are the administrative scope or the architect scope of saying things, oh, what's happening in my system? Starting with simple metrics to more complex insights. Right? So, and then there are third-party brokers, and of course, all these things come down to the developer. How do they interface with this broker? Streaming APIs, connectors, the whole nine yards. So, this is our platform, Solus platform, is built on these. All right, but it's a representative of pretty much all the brokers. There may be a little variation here and there. So, I just want to put up a platform notion, not just a plain architecture. Architecture is something theoretical you can read up and then adopt. But when it comes to real world, you need a platform that involves all these components. All great, but just like anything new, we have plenty of challenges. Right? Depending on what role you play, depending on what you have in your organization as a challenge, maybe starting with skills and knowledge pool, buy-in from the management, availability of tooling, and then protocol support. Oh, I want this on WebSocket, but these guys don't support WebSocket. How many times you have run into that, right? So these are different aspirations from the whole stack of personas that are being involved in media. Developer, DevOps, architect, CIO, you get the picture, right? So all these things are challenges. Depending on the project, depending on the client, some of them will be highlighted, some of them will be a non-issue. Collaboration is not even required, right? Wherever, for example, I don't need collaboration. Somebody may say, no, I want my EDA to be accessible in my Slack or Confluence. I need to be integrated with Jenkins. So the dimensions are many, but challenges are equally many either. Also, okay? So,
Cost here.
no, we don't talk about cost. We are architects, man, right? We just give the best of the best.
Okay.
Cost is a factor, I'm not denying that, but all the vendors have different approach to this cost perspective. They have class of service.
Okay.
For example, in our case, 10K broker, for example. That means 10K users or clients can simultaneously be connected. 100K and so on. So you get the picture. So this more directly involves how the broker vendor slices his offering. Yeah.
I want to bring one point which is a pain point for most of the products which we do.
Yep.
Is on the dimensioning part. Okay, so the
It's
thing
on the
is
side.
dimensioning. So when you run a product on a scale, so you spend a lot of time in dimensioning the memory, the CPU, the disk.
Yeah.
Okay, so all these things comes into picture. That's where the customer pays actually. So they always ask for whether your product can run on a lower dimension with that much scalability. So you still need the scalability,
Right.
but you need on a very lesser dimension.
Understood.
Okay, that is the part, the money part which we are talking about, right? So how much customer is spending for running his system? Like he has deployed a system, but he don't want to spend more on the.
I totally hear you. I can talk about our product, Solus. Solus is the name, just remember, because when I keep referring to Solus, I go, what is Solus? So Solus PubSub Plus is our broker and our EDA solution, right? The approach we have taken is, what is your priority? High throughput, low latency, like a banking or capital markets. We have an appliance solution, low cost of ownership, CapEx. You deploy it, you got your things in place. And it has a limitation, then you choose what class you want. Within the appliance there are grades, right? And then, oh no, I'm an in-premise guy. I just want software, I want to own everything. I want to administer. There's a software version. Right? The moment you get a software version, you become responsible for provisioning these resources. So it's up to you which machine you deploy. Third one is, no, I don't want to take any of this overhead. I want cloud. I want GCP because I already have a contract. Half of my system is running in GCP. Somebody might say I'm running on Azure. We are game for that too. So we support our product on cloud, Azure, GCP, and Amazon, AWS. In fact, we have partners with them as well. Right? So there you get this class of things, 10K, 100K, 5,000K or whatever, right? So these are all limited by the connection. Right? Basically behind the scene, if this many consumers were active, how much storage will be required, how much memory, those are all factored in. When you present this price list, you just need an abstraction. The devil is in the details. Those are all optimized for that class. That part we take care. So like that, every vendor can easily and definitely come up with a scheme that fits the requirement. And in fact, I'll tell you, we have a 60-day free trial account for the cloud. You and me as an individual, you can go sign up on the cloud. Without even downloading anything, you can get the EDA going. If you want software, download a Docker image. That's also valid for 60 days. Not 60 days, it's indefinite for a limited use of, I remember, 1K users. 1K, thanks. By the way, my colleague Suresh, so we are from Solace. So all these questions are valid. We highly recommend that check it out. Right?
Coming back to technology.
Yep.
See, when you said, let's take it event-to-one, you took publish subscribe model, which is very much suitable for a business model. That this event-to-one looks like that. I will take data and test. In that data is also event you told me,
Yes.
right? So I am finding this event-to-one is very much suitable for this publish subscribe model. But my question is, how do you do that kind of event-driven thinking in the data analytics?
Okay, it's a very interesting question. I would not be able to answer it in one sentence. Maybe after this session I will talk to you. There is something called a stream analytics. When you have data, you just stream, right? So whoever is subscribed, it's a tap that's flowing. Whoever want data, they can tap into it. I mean, that's a simple way of saying it. But here it's controlled. You subscribe to an event, the stream is flowing, you will get a slice of the stream, appropriate to your subscription, right? So the analytics on stream is a very relevant thing because it's a real-time analytics. And then there's obviously the complex business problem, all the things that we looked at. IoT phase one, fleet management, airline management, capital market, these are all business problems. Analytics is a subset. And there are specialized tools. So should it be done with event-driven? Yes and no. Depends on the use case. Yeah.
Yeah, I got a question so like you said that it is a PubSub model. Kafka is a PubSub model. Is it a competitor for Kafka?
We are not okay, well, that's also another interesting question. See, Kafka is basically, how do I put it? It is a PubSub layer, kind of layer on top of a log file. Right? So you are streaming the data.
Log file is internal implementation of Kafka, but on the top you have got a PubSub model.
You get a stream, PubSub,
Yeah.
right? But there's a lot more to it. Can we deploy, Suresh, you want to chime in on that?
Yeah. So,
But we got to watch out for time, otherwise we will...
you can see the timer there.
Oh yeah?
The timer is running there.
Oh, it's 19 minutes up. It's not okay.
90 minutes rest remaining, pending.
Then everybody has to talk to us offline then.
So, okay, at a high
Can
level, right?
I know.
Yeah, at a high level, so though it's a PubSub, that's okay, I think. I'm audible, right?
Yes.
Okay. Though it's a PubSub, so there is an architectural difference between these two products. So it's a log shipping, Kafka is a log shipping, and the way you subscribe to a data within a Kafka is you have to predefine on which particular instance it is being stored, all the topics, because it stores the topics in a different instances within the Kafka. So in a connector, you have to define exactly, hey, from which slots of, from which instance of the Kafka I have to pick up the data. But in our case, that is not needed because it's not a log shipping mode. Directly you can, using any standard of protocols, it can be AMQP, JMS or WebSocket, anything you can take it, subscribe it to a specific topic, you will get the data. But in case of Kafka, you have to use their own connector architecture. And that is, if you get into the commercials, Confluence will sell the connectors. Here, in our case, it's just an open standard. You don't need to, it doesn't need any kind of a connector architecture, it just uses standard protocols. That's a high level at architecture. There's a lot to discuss to clearly bifurcate or differentiate what we are and what Kafka is.
Right.
See, one quickly on that.
Yeah.
Same. Kafka also has a broker pattern there, we can use that.
Yes.
It's already there. This event broker which you were mentioning is there already, right?
So think of this way.
It's a simple.
If it is just a matter of publish and subscribe, you and me can write a program that can do publish subscribe.
Okay.
Right? It's not about that. The value add from an enterprise scale perspective,
Okay.
event management portal, protocol, multi-protocol translation support, connector support, and then form factors, right? And then cloud deployment, governance, security. These are the things that enterprise will check mark when they choose a product. When you talk about plain Kafka, by definition, yes, it can do PubSub. It can do EDA. But is it ready? When I say EDA, meaning the core functionality. But is it ready for enterprise? To a scale, yes. But beyond the scale, you would ask for all these things, and that's where you will start seeing the difference.
Okay, it looks like a sub-module of a EDA, you can say.
It can do EDA. I would stop there. The reason is, you can do everything with the Kafka, but open source. Remember, are you willing to take up ownership of?
But it's not complete EDA, you can say part. Right?
Yes,
Yeah.
yes. Right?
Maybe a couple of points. So there is in Kafka.
We got 16 minutes. Can we take it offline?
Maybe we can discuss.
Yeah, please offline. We would love to talk to you. No worries. So I'll try to speed up now. The simple thing is, I'm here to bring out the perspectives. As with anything new, we have expectation or at least perceptions. Like, what is this about? Let's start with the developers, right? So when it comes to developer, all they care about is whatever the system that you choose for your business implementation, a tooling ecosystem, support for APIs and frameworks, reference implementation, community support. And on the right hand side, you can see the standard things, right? Without this, a product does not become an enterprise product. Whether it's EDA or a CRM or anything, right? And EDA is something new. It's all kind of a, what do I mean by saying that CI/CD in EDA? That's a big question to talk about, right? So like that, but still that need to have all these things, and they need the ability to kind of make it easy to error handling and retry mechanism. If something that you need to bootstrap, build on your own, that's trouble, right? The system should have facilities that you can tap into and build on top of it, more sophistication. So these are the typical expectations from a developer, and obviously we are talking about messaging, right? Message exchange patterns matters a lot. You shouldn't be coding these basic things, simple point-to-point, request-reply, PubSub, processor. All these things should be made easy for you, available for you to use, right? And the last but not least, we all always look back to something that we all relate to. Hey, REST is great, we have open API standard, there's a Swagger tooling system, I can do code gen, I can go on production overnight. True. Something is evolving in this new domain, that's called as async API, right? So it is a standard tooling system. You can generate code, and when it comes to code generation, EDA is wide, far and wide. It requires, or rather it supports more protocols than just a plain HTTP. AMQP, MQTT, WebSocket, and of course REST. On top of it, there are some proprietary protocols. And the code generation, it's not just like the Java, Node.js, .NET, Core, Java, JCSL, so many things, right? So the standards are evolving, bringing parity to make developers' life easy, right? And architect's perspective, they always look for simplest solution that works. That means fewer dependencies, so that they can evolve the system independently. They can scale during the development also. Failure isolation. Tell me an architect who doesn't care about it. That's the first thing they would say, right? And then evolvable architecture. This term is pretty interesting. When you see that video that I'm recommending, you'll get that. Basically, monolith to microservices is basically break the complex problem into smaller microservices and scale, right? It's the same thing. But as you're scaling, leave room to evolve to the next level, right? So I can talk more on that, but being time conscious. Integration support. As an architect, I don't want to be building connected to an ERP. Even if it is a commercial, sure, but I want support, right? So the integration is another key thing an architect would look for when you choose a product or architecture for a solution, right? And on the right hand side, you can see all the things: concurrency, parallelism, fault tolerance, DR, high availability. The most important thing is observability. One of the pet peeve about microservices in an architecture's perspective is, I don't know what the heck is going on. I invoked, I got no response. Did it time out? Or did the network break down? Observability is the biggest problem. And event-driven is a foundation for decoupled microservices, event-driven microservices. If at all anything can be done, it can be done at the EDA level, right? And it's the right place. Observability is the most critical thing an architect should look for when they choose the EDA as a choice for the implementation. Right? So what do you mean by that?
Quickly, that observability is part of Evolve?
Broker.
Evolve?
We have it.
Huh?
Yeah.
Okay, that's good.
And then integration perspective, I talked about this, iPaaS integration, and then the protocol specific AMQP integration. These are APIs. Integration meaning it could be an API or SDK, or it could be a connector. So there's a broad set of things that an enterprise would need. I'm not talking about mom and pop shop. I'm talking about the retail industry giants, from Walmart to Kroger to and then airlines like big names. Now, I cannot quote, but you get the picture, right? Observability is the question that you were asking, right? If a message is published, where exactly it went? I want to know with the timestamp. Did it make it to the customer? Was it received? Why they didn't? And then, remember, I also want to introduce one thing. A broker is not necessarily a single piece to help you in the routing. There can be multiple brokers collaborating with each other. That fabric is called as mesh, right? We'll touch upon that quickly. So, as an architect, you would look for observability as to what's happening with my event, right? Being able to, non-repudiation is one of the key principles that you would look for, right? Now, it comes down to these 6 or 8 pieces, right? Was the event published? When? Who? What time? Which broker? Was the event received or enqueued for the subscriber? Maybe it's queued but never got drained. Or maybe it's queued but expired. There are so many classes, right? All those things, broker is the right place to bring in observability. That means your microservices can be thin. You don't need to make it bloated just to support this tracing, right? The next best thing is, in API world, we know that API product. Why not manage the API as a product? That means associate a lifecycle and manage it through governance principles that you have. We know RPG, familiar? Gravity, familiar? These are all API management tools that made wonders for the REST world. Schema repository, validation, versioning, and then this scaling aspect, security aspects, permission, access control things. All API management is kind of managed by these tools. Those kind of tooling ecosystem is evolving, but there are 2 parts to it. Maybe we can come up with something for EDA, or maybe why not converge with something existing. The convergence is coming. So what I'm going to talk about is quickly this one. 9 minutes. All right. So in our enterprise, as you stand today, you name it anything: inventory management system, customer management system, order processing system. All these systems today they are REST-based. You send a request, they will respond to you back. But in the processing aspect, from the request to response, there's so many things happening within those applications. They're all noteworthy to be generated as an event. Meaning, let's say, in this case, if you look at it, order management system, there is a request, order placed, right? That's the request. API to place the order comes in. The moment order is received, maybe it can publish an event saying that order received, right? Next, it can say that order processed when it does the validation and it kind of passes all the checks. Next one is order shipped. So all these things are basically intermediate transient points in your processing. They can all be kind of pushed out to the real world in the form of events. Today we are not doing that. API request goes in, response comes back. It's as if a conversation between 2 parties. But behind the conversation, what's happening, they are all noteworthy events that can be made available to others. So expanding on this, we have another system, warehouse, stock allocated, a product catalog, right? All these guys, based on the support they provide to their application ecosystem, they can generate these events. That's the first part, right? Once these events are generated, now imagine when we have the ability to bundle these events appropriate to my business requirement. Received, processed, shipped. This could be of interest to a delivery service provider, right? When an order is received, delivery service provider should become aware. Hey man, this week it's going to be heavy. Looks like so many orders are there scheduled for tomorrow. So I need to maybe scale my human resource. Or it could be process or shift. That means I need to go pick up, I need to get extra hands. Or maybe I need to choose, I don't know, the price management. There's so many things that are specific to the delivery service provider. This guy is not even part of the ecosystem, if you notice. Now you can bring him and make him participate when you expose them as events. But can you ask them to write an event-driven program, subscribe to these events? No. You expose them as event APIs, something that we are all familiar with, right? So this bundling of these events together and making it available as an event API. In this event API, we're not going to be talking about request response. We're going to be saying publish, subscribe, right? So go to the next slide. So you got the picture, right? Bundling these related events, making them available as an event API, and even treating them as a product so that you can lifecycle manage. That makes it so easy for others to participate. What we are looking at is a picture of, whatever the API that we know, we feel powerful. And whatever the events is doing, that is also equally powerful. Let's combine these things. That's what it is, event-driven APIs. Best of both worlds. This is the one that leads to the next one. That is, I'm going to quickly wrap up this part. See here, this is what I was talking about. Your system generates so many events, and few of the enterprises may be equally interested. But today, we have them talk to each other using REST API. Let's stop that. How those applications subscribe to these events. So even internal consumption can be event-based, right? On that, you collate the related events and bundle them and expose them as an event API product. You just give the spec, give the endpoint detail. The third-party application could be subscribing to these events using event API products. Now you are talking about integrating external parties with these, right? So this is the way. And how does it work? Just like our APIs, there are ways to do. Discover the system events. What are the system events that exist in your system? And assess the usability and value. You don't want to expose every event. User logged in. What is of interest to anybody, right? So you've got to qualify which is of business value, right? Assess the usability value, bundle them, document these high value events that is of interest to other applications in your ecosystem or maybe a third party, right? And expose for consumer, right? And then evolve and optimize, a cycle. So all these things are great. We have talked about everything, APIs, data mesh, iPaaS, analytics. But what it means, at the end of the day, it comes down to these two pieces. A real-time connected enterprise needs an event mesh and event management. When I say event mesh, I'm not referring to one broker. It's a mesh of brokers, depending on your need. What is mesh? I deploy one or more brokers to serve a purpose. That gives me an option. Maybe I can have a network segmentation. For APAC region, I allow one broker. For US North America region, I have another broker. So those kind of topological aspects can be factored in. That's why it's not referred to as event broker anymore. It's an event mesh, a mesh of brokers. And then obviously you need a management tool or a platform that can help you manage everything, right? So in here, let's get down to this part very quickly. What we know in APIs, we know API gateways that provides you the runtime aspects, right? So all the coordination between APIs and service consumption, very good, well done. And then you also have API portals that helps you kind of orchestrate this entire design time activity. Contracts, schemas, applications, permissioning, the whole 9 yards. Very evolved one. What you get at the API portal is you catalog of APIs available for consumption. And one can come and just simply discover, is there anything of interest to me? It's open, discoverable, share and reuse, analyze, extend and design, and generate code. I'm referring to our open API Swagger ecosystem. And technically, RPG, Gravity, whatever you go, at the end of the day, they provide these great facilities. So it's pretty evolved, right? Nobody is doing anything different than this. When it comes to event-driven architecture, we have a good knowledge on this event broker aspect. We know how to enable publishers and subscribers to communicate with each other using events, right? And then how about the design time aspect? That's where this equivalent of API portal comes into picture. That is what we call as the event portal. Event portal is a unique product component in this EDA that is available only with Solus, right? It's incorporated / integrated with other cloud vendors as well. I cannot name, but it's seeing a huge adoption. There is a demand. When EDA grows, first thing that people ask for is, oh, you're great in low latency, high throughput. What about the management? An architect's first question is governance. Governance is an umbrella word that covers everything. And this piece was missing in EDA. Now we got the dots covered. Right? So technically speaking, what you're looking at is this picture. Convergence is happening already. Right? So why should I use event-driven? I can do everything in REST. No problem at all. We are not killing one thing to bring up another. It's about coexistence, right tool for the right job. EDA may not be the right thing for you. depending on the use case, choose the right tool. So today we know this. There is a network layer, on top of it, Kubernetes does the job of your deployments, containers, blah, blah. On top of it, we have service mesh, which is something equivalent for the API worlds. And we bring in event mesh of brokers. What you see at the top of that is the types of services, microservices. We already know we have request reply microservices that's operating on the API framework, right? And we already know event-driven microservices way right now. Everything is, most of the things are built as event-driven microservices, and they use event mesh. And event mesh can bring third-party brokers like Kafka broker, RabbitMQ broker. Those are all quite a possibility. Today we support Kafka. And then you can also have a hybrid microservices. With this, what you're looking at is a unified sync and async API management that's built on open standards. Again, we're talking about open standards. The architect would love it, right? You don't want anything proprietary to creep in. And then, after 2 years, you're stuck with that vendor. At least it's open standard. That helps you to expand your base in terms of consumption as well as adoption, right?
Could you
So-
just go to the previous slide? Yeah. What do you mean by event portal? Like website where we can get the detail of the event or other than that?
Okay, here it is. In an event portal, the key things, design time activity. What do you do typically? Oh, I want to create an event. Event has a name. Okay, what does it go in with that event? A schema. And then what's the format of the schema? Is it Avro, JSON, XML, all the way down to what application can publish what event, the permission, access control. And then you can also talk about runtime. I want to make this application available in a draft state, release state, versioning, and then production, dev. You see the picture? The whole design time activity is a lifecycle management centric. That's exactly what is offered by the API portals. Now you get that via event portal for the event-driven architecture.
So, event portal of Solace, is it a separate pluggable component that can be used on other event brokers?
Two ways to look at it. You can discover events in other broker.
Okay.
So we have discovery agents, AWS, Kinesis, Apache Kafka, and there's probably one more. We can discover and bring those EDA and then manage over here. Yeah. Okay. Sorry, I didn't mean to rush, but just to be sure that we have. Okay, the last piece is about how much time? I'm done. All right. That's about it, guys. So the last point I want to make is, don't think that EDA is an in-premise solution. No, it can be hybrid. It can be cloud-centric. It can be hybrid cloud, multi-cloud, right? Just one picture will speak for everything. With that, I will close. For example, if you look at this, a company running a solution with a on-premise trading module, right? It's a complete on-premise solution using local systems like NoSQL, everything managed internally. They want to move to cloud. That's their mandate. How do they do it, right? So the first thing is, event enable your local system by putting a broker. So anything that qualifies to be propagated, let that pass through the broker, right? So that's the first step. After that, create a parallel setup on a cloud instance, the first instance. Let's say that one is US and this one is APAC. Put a broker there, and this broker and the on-premise broker, let that be meshed. So all the events starts flowing in each other direction. And then on this PubSub broker, build your stack. This time, go cloud native, as in use the S3, REST connector, whatever the cloud provides, right? Now you got your on-premise and a cloud instance collaborating with each other in real time without even you changing anything. You didn't have to rewrite any code, remember that, right? And once it is done, make this full stack. So you got an in-premise solution running on local stack, a non-cloud application, and full cloud stack with a cloud-friendly, cloud-native application. Once this is done, you are incrementally enabling or reducing EDA into your picture. Now, recreate this setup with the mesh. When this is done, whatever for example, is a trading model, right? So NYSE trading information can flow in any of these directions to broker. When it would flow, then again, you will be wondering, oh, it's going to flood the network. No, subscription based. If there are anybody subscribing to that on this side, then that particular piece of information will flow. That's the dynamic message routing. These are all not part of a simple broker. These are the broker plus plus. Now, not every broker has it. And then, if you talk about, I will stop here, just quickly, Kafka will be like a topic based, right? Topic is monolith, it's literal. We have hierarchical topics that gives you a lot more flexibility in controlling what subset of information that you want to pass. Right. So I'll stop here. Maybe few questions, and then we can go offline.
Are there any numbers you can share, like the throughput numbers, like X million events per second or something like that? I know it is subjective, but any rough guideline?
We can only boast about the biggest numbers.
Do you have the data sheets available online?
Okay, I can check.
One of the Black Friday events was 1.2 billion or 3 billion events in a day, our broker handled. And one of the capital markets, close to, anywhere from 300,000 to million events.
28 million per second roughly for the...
28 million per second.
Yeah, that's
28 million events per second.
Yes.
Oh, wow. That's an appliance we're talking about. That's the topmost...
Got it.
High performance.
Yeah, that's fine.
And R2 with 18 microseconds as a latency.
Okay.
Low latency, high throughput, that's our mantra.
Yeah. Which programming language it is written in?
So,
C.
Everything.
Appliance is purely based on the network based. It has its own network cards.
Okay.
Same thing we emulated in the C program for the software brokers.
I see.
It's on,
That's right.
on C.
Okay. Nice.
Technically, you can say C and C++.
Yeah.
And there are other add-ons that came in later.
I have worked on complex event processing.
Oh, great.
There's a product called Apama. You have heard.
Familiar, but not
I have worked on that.
okay.
So basically the idea is that an event can be complex. For example, within 10 seconds, if this particular, trade or particular instrument is right, its price changes by 10%, take this action. Or this sequence of events followed by this sequence of events. On multiple streams of data, you can react based on it. Right? So is it a completely different paradigm from this, or
It's a subset.
it's a subset?
See, what you're referring to is basically stream analytics. So it's not just analytics from a metrics aggregation, it's a little bit more than that. Conditional evaluation on a live stream, right? We don't get into that game, we leave it to the consumer because there are sophisticated products. Apama was there, and then there's one more product that I know, forgot the name. They were specialized in CEP. They used to work with all these stream capable applications. Stream engine. There you go. So we support all of these guys, right? But we just don't take it upon ourselves. Our thing is kind of barebone plumbing. Move the bits the fastest, efficient way, and then provide connectors to you. You want this data to land somewhere else, like a MuleSoft? Sure, we have a connector. You want it to be available in a Node.js application that you want to build? Sure, we have API for that. So to that extent, we have created an ecosystem. See, this is the point I wanted to call out. The middleware and integration got bloated because they did a lot more than messaging. Eventually, one message to process, it goes through a truckload of validation. It's not a simple pre-post conditional. And we cut out all those chaff and focus only on this. So this one is interesting. We can do it outside.
And I have just one more question, maybe it's very basic. So generally when we design applications which are event-driven, right? The sequence of events becomes very important, right? So what
Order.
kind of,
Order.
how do we ensure?
Oh, we are best at it. Ordering is our bread and butter. Capital markets, stock exchange, airline, our use case talks for itself. Right? Ordering is ordering and guaranteed delivery. Absolutely. We do support it. So the one last slide that I know there is a lot of enthusiasm.
How you take care of the ordering? Like, could you highlight that? How you take care of the ordering of the events?
You at the end of the day, remember, it all comes down to how you dequeue from the queue. There you have control. You can have a active passive mode. That means there's one active consumer draining from the queue. Ordering is guaranteed, right? When it goes down, the other guy can come up and then continue where it was left off. Fair enough? This comes down to the queuing, right? The order in which the events enter the queue is, and all about is how do you allow people to consume? Out of order, in order. We support both as a class of service. There's a lot more information available for you. Join this community. Even though I touched upon a few of the things, there are complex requirements. You cannot even fathom architects level discussion, right? So a lot of things get discussed. Even if you don't use our product, that's okay. EDA awareness is something that can go multiple notches if you participate and just read through the conversation, right? And of course, I am based out of Bangalore, so is my colleague. We are a small team out here, all are remote. Feel free to connect with us wherever we can help you with your EDA requirements, just for a discussion, or maybe you are choosing, evaluating, you have questions, we're more than happy to help. It's not about selling, right? We just want to create this awareness, make EDA mainstream. We are doing EDA, but without even realizing it's EDA. Let's kind of stamp that as EDA and get the best out of this. Okay? Thank you guys. We are available for offline questions anytime.